In the previous video, I reviewed how to create the basic link node structure of our network. In this part 2 of the tutorial, I'm going to demonstrate how we make the necessary link and lane connections to ultimately allow us to run our simulation. So I've loaded the network from where we left off in the previous video. I'm going to display the network info panel pane and then also press the network edit tools button and then press the network coding check panel button. And that will display this panel down here at the bottom of the screen. A feature that will be useful to your network development is going to be this check for network coding errors and warnings. So I'm going to go ahead and press that. We see that there's quite a few things that are now displayed in this panel. If you have a lot of errors, it may be easier to view these in a text editor, and you can click this copy text to clipboard, and that'll select all the text and copy it, and then you can open up your text editing app and paste it into there. The reason we have all these errors right now is because we haven't specified all of the link connecting information and lane connecting information. So for the simulation to run, we need to tell it what links connect to which links, what lanes are connecting to what lanes. And so we'll go ahead and go through that process now for our example network here. And for now, I'm going to go ahead and turn off this network coding panel. Again, if we refer to the wiki documentation, we'll see that the information on the connecting links and the connecting lanes are specified here. We'll need to set these properties within the edit link data dialog for each of these links, and there's two ways that we can bring that up. So one way is we can come over here into this panel and we can just click the edit button next to a particular link ID. We can also right click with the mouse button and we'll have a context sensitive menu that will pop up, and we can also select edit link, and that will bring up the same link data dialog. I will start with the entry link 7011, and these link IDs are created from a concatenation from the upstream node ID and the downstream node ID. So I'm going to select edit here. This section here of the link data dialog is where we're going to indicate what links upstream of that link connect to it, what links downstream of that link connect to it. Now in the case of an entry link, there are no upstream connecting link IDs. So we're going to leave all of these settings at 0. So 0 indicates that there's no connecting link for that particular movement. Each link supports 3 different movements: a left, a through, a right. For downstream connecting link IDs, we only have one link that connects. That's a through link, and that is link ID 12. You need to be a little bit careful with this and make sure you don't have any typos. But if you do, the network coding check will catch that. So for now, I'm just going to go through and set all the connecting link IDs, and then we'll come back and do the connecting lane IDs. I'm going to save changes. Now we'll go to link 12. So link 12 has one upstream connecting link ID, and that's the entry link. And its ID again is 7011. And then it has one downstream connecting link, and that's 34. This is link 34. That's how we set it up initially. There are some other nodes in the vicinity, but this node 2 is specific only to this link. This node 5 is specific only to this through link here, 59, and this node 6 is specific only to the right turn link 67. Next is link 34, and for this we have just one upstream connecting link, 12, but now we have 3 downstream connecting links. We've got the left turn, the through movement, and the right turn. So the link ID for the left turn is 48, And the link ID for the through movement is 59. And the link ID for the right turn movement is 67. Because we're allowing a right turn from lane 1, which is the outermost lane, I do need to change this turn movement to a through plus right. And we'll come back to turning percentages a little bit later. So again, we have 3 connecting downstream links here. 4-8, the left, 5-9, the through, 6-7, the right. Next is link 4-8. And for 4-8, we just have one upstream connecting link. We can use the through movement. Vehicles that travel onto a turning link are considered through vehicles. Downstream, we have the exit link, which is going to be 8803, and that is also a through movement. And then we'll go to link 59. 59 also has as its upstream link 34, and then downstream is going to be an exit link 9802, and then we'll go to the right turn link 67. Again, upstream link is 34, and the downstream link is the exit link 7801. Now we just have the exit links left. We'll start here with 7801, and its upstream link is going to be 67. And there's no downstream link, so again we're going to leave all these at 0. Go to 9802. Its upstream connecting link is 59. Again, leave all the downstream links at 0. And then 8803, the upstream link is 48, and all zeros for the downstream links. Next, we need to specify the upstream and downstream connecting lane IDs for each link. So again, we'll go back to our entry link, and for these settings we're going to need to go into each individual lane and select the edit button for the connecting lanes. So first we'll go to lane 1 here, and just like for connecting links, if there is no connecting lane, we're going to leave these IDs as 0. So in this case, lane 1 on this link connects to lane 1 on the downstream link. And then likewise, lane 2 connects to lane 2. You can display the lane IDs on your map, and there's a button for that here. You can toggle the lane IDs on and off, and that will help with this specification. And again, the way the lane numbering works in SwashSim, the outermost lane of a link starts with number 1 and then increments towards the inside of the link. Next is link 1, 2. We'll start with lane 1. And since we have an upstream connecting link, we're going to have potentially a lane to connect to as well. In this case, lane 1 again connects to lane 1 on the upstream link, and it connects to lane 1 on the downstream link. And then lane 2 connects to lane 2 upstream and lane 2 downstream. Now for link 3, 4. For lane 1, that's going to connect to lane 1 upstream. Now downstream, we've got 2 possibilities, because you can have a through movement from this lane, you can have a right turn from this lane. So for the through movement, lane 1 also connects to lane 1 on the downstream connecting link. That's link 59. For the right turn, it connects also to lane 1 for the right turn link, which is 67. Now for lane 2, it connects to the through movement upstream on lane 2, and then connects to the downstream link, lane 2 as well. For the left turn lane, it does not connect to an upstream lane. It's a separate left turn bay that's added only on this link. So again, we're going to leave all these at 0, and then downstream we're going to specify lane 1 for the left lane ID. For link 4.8, in this case, we're going to say 1 for the upstream through and 1 for the downstream. Again, for these turning movements, we're going to consider the vehicles as being through movements on those particular links and lanes. Link 5.9, we have 2 lanes on that, and upstream lane 1 connects to lane 1, downstream lane 1 connects to lane 1, lane 2 connects to lane 2 upstream, and lane 2 downstream. For link 6.7, again we will use upstream connecting through lane 1, downstream connecting through lane 1. Link 7801, an exit link. The upstream connecting link is going to be through lane 1, and we do not have any downstream connecting lanes, so we're going to leave all those at 0. For the exit link with 2 lanes, again, upstream connecting through lane 1, no downstream connecting lanes. And for lane 2, upstream connecting lane ID 2, no downstream connecting lane IDs. And for link 8803, again, lane ID 1 for the through lane upstream, and no downstream connecting lane IDs. Now let's do a network coding check and see where we're at. Okay, so the good news is we're not seeing any errors related to upstream downstream connecting lane or upstream downstream connecting lanes. We just have one error showing right now, which is that the entry flow rate for entry node 701 is equal to 0. To specify the traffic data then for the entry links, we can right click on the link and select edit traffic data. And now we get our traffic data screen. We'll just go ahead and enter a flow rate of 600 vehicles per hour. We'll leave the other settings as is for now. Make sure you click the Save Changes button. And then you can close. And then let's check for errors again. No network coding errors were found. At this point, we should be able to run the simulation. However, there are a couple more items we'll want to set before we proceed with running the simulation. Now I've already gone ahead and done that, but we'll go ahead and look at those settings in the edit link dialogues. So one is the free flow speed, and that is in units of feet per second. I've just entered 50, which is about 34 miles per hour. Same thing for link 1.2. Likewise for link 3.4 and link 5.9. I've also set those speeds for each of the 3 exit links, and another way to check that is whenever you select a link in the panel over here, you can check the free flow speed in this box up here. So for the turning links, I've reduced the speed. So for right turn link, I've set it to 15 feet per second, which is about 10 miles per hour. And then for the left turn link, I've set that to 22 feet per second, which is about 15 miles per hour. And then the other thing that we're going to want to set is the turning percentages for links that connect to more than one downstream connecting link. In this case, it's link 3.4. We have a left, a through, and a right. Now in this case, I've specified different turning percentages by fleet type. We have 4 different fleet types. We have a number of different vehicles that are specified in the simulator, but they fall under one of these 4 different fleet types, either a small automobile, large automobile, small truck, or large truck. Now you can just do general turning percentages with these settings up here. So those turning percentages will be applied to all of the vehicle types. but there may be situations where you want different turning percentages for different vehicle types, and so that's specified here. Now we are ready to run the simulation, which will be discussed in a subsequent tutorial video.